So in the first episode of this PICO-8 series, I showed you how it works and what you can do and all the tools that are in here, like the code editor, the sprite editor, the map editor, the sound effects editor, and the music editor. And in this episode, I want to show you around the language itself. So this LUA scripting language, I want to go into a little bit more details about the parallels of the LUA language and the C64 BASIC, which might be the BASIC most of you out there know, or the ATARI-Basic, which is pretty much identical. So yeah, let's start with some simple things like variables. So a variable is some place in memory which has a name and which can store a value. And just like in Commodore BASIC, you just use a variable. There's no declaration like in C or Java where you say which type it is. So say you want to store a variable called x, you just give it a value and there it is. And based on the value you give, the scripting language knows what kind of variable this is. So this is a number. Let's say you want to have a string, which would be, let's call this some text. And just like in BASIC, you type it like this. And let's say you want to have a Boolean value, which can be true or false. You just say it, some bool, true or false. One speciality which you have in LUA, but you don't have in BASIC, at least not that kind of type, is tables. And you can think of a table pretty much like a keychain, which has a name and which has different keys, and these keys can have different types. So let's say you have, for example, a player. Let's call this player 1. And now you can give this player, say, an x value, which is 10, or a y value, which is 20. Because I forgot to put the equal sign here. And now if you run this, you see nothing happens. That is because we don't use these variables. So in the last episode, I already told you that there are 3 basic functions that make up a game. And the first function would be the init function. And a function is pretty much a block of code which is executed, and PICO-8 works that way that for every program start it calls this init function once, and then there's a function called update, which is called 30 times a second, or if you use the update 60 function, it's called 60 times a second. And then there's a function called draw, which PICO-8 also tries to call at least 30 times a second, or 60 times a second if you use update 60. But depending on how much there is to draw on the screen, PICO-8 may reduce that number of calls and focus on the update and draw less than 30 or 60 FPS or frames per second. So to do something, you have to put code into these functions. And if you want to do something once, you put it here. And for example, let's say we do a print hello world. And print is a function, so we have to call it with these parentheses around it. And we say we want to print some text, which is the variable we used up here, which has hello inside. And we call this hello. Change this to hello world. I'm sometimes pushing the shift key and then I get these strange characters because I'm used to writing like a human being and using upper and lower cases, but PICO-8 only supports upper cases, so there's no point in pressing Shift. We press Escape and type Run and get Hello World, or Hello World in this case. Let's correct this. The editor pretty much works like any other text editor. You can run around with your cursor and do stuff. And if, for example, you want to print the X coordinate of the player, you just say player.x. Yeah, but it's called player1, so you should also call it player1 here. Let's try this again, and there we are. And the same goes for the Y coordinate. If you want to print that, player1.y. So that is a very neat way to group variables that belong to an object in object-oriented programming, which you could also do with Lua, but we won't get into this. You would actually separate the objects into different classes and stuff like that, but we won't do that here. What we can do, however, is we can put this kind of code, say the player code. I will cut this out here, and we can put it into a different file, so that we at least have some organization in terms of which code or code separation file-based. So if you run this now, you can see it still works, even though this is in a different file. So all files are automatically included. If you are coming from C or Java, you normally have to include different files, but not here. Everything you type in this editor, no matter in which file it, in which tab or file it's stored, it's still used globally. Okay, so that is that. Then we have the classic operators, which are derived from C. So if, for example, I want to add something, let's say X is player 1.x plus player 1.y. Then we do an addition. So we add y to x, or player 1.x, and if we print that and do this, we get 30. Cool. One speciality, if you come from BASIC, is that the equals operator is actually the double equals sign. So if you want to check if x has a specific value, you say if x double equals 30. So this is the assignment and this is the comparison. That can be very frustrating if you do this. Normally you get an error. Let's check if we get an error. And we have also a then here and an and that closes this if statement. And you can see it says expected, closing brackets, expected near, because it's missing the second equals. Yeah, so all the things you want to do if x equals 30, you can do in here. Let's say you want to print very cleverly, it's 30. And it is, so it's 30. So that's the if. There's also an else if, which is written exactly like this. If you type else if, you will get errors, and these are not very descriptive, so you might get angry like I do often if things don't work. And you can say else if x equals 20. And whoa, like Anakin Skywalker at the end of Revenge of the Sith. And we also have the else, which goes like this. And again, I press the shift key. And again. So, okay. You also have to type the then here. So every if, no matter if it's just an if or an else if, needs a then at the end. So this is for checking if stuff is stuff or not. And you have also the ability to concatenate stuff with or and. So you could also say or y equals 10. That should work. And the same goes for the and you can concatenate as many as you like. We had functions, but you can have functions with parameters. And that works like this. You say function. And then let's say this function is called add, and you add a and b. And then you can return a value, which is return a plus b. A plus b. And now if you say add or x equals add 10, 10, and then you say print x, that should be 20, and it is. So just like that, you have functions, and this return statement returns the value and assigns it to a variable if one is here. Next thing we have is loops. You may know loops in form of the popular for next statement in BASIC. And here it is not a function but a keyword, so we don't have to do brackets. And it's a little bit like BASIC, so you can say like for I equals 1, 1000. In BASIC you would write 2000. That's not in Lua. And you don't type next but end. And you can then, of course, print that. Right, and we have to put a do at the end here. So for I equals 1, 1000, do end. And as you can see, it's counting to 1000. If I let it, which I don't. Yeah, that is that. There are some more of these for statements which you can use on tables, for example, but we will not go into this right now. We will use these in the game probably. So probably the most interesting stuff in all of this Lua and PICO-8 environment is the ability to use graphics commands, which was lacking in the C64 BASIC. It was present in the ATARI-Basic and the C16 BASIC and all these, but you couldn't do it on the C64, at least without using pokes or assembly language. And that is great about the PICO-8, because you can simply go and draw up something. Let me quickly create a little character like this. And we can then go, and this is sprite number 1. You can see if we switch here, we have the different sprites. We can just go and put it on the screen. If we use the draw function and say spr, which is for sprite, and we say which sprite, and we say where. Let's say at position 1010. If we type run, there's our little sprite up in the corner. To make it a little bit better visible, let us clear the screen, which is a function, cls, clear screen. Again, you have to use the brackets. And there he is. And if we wanted to move the sprite, we could say expose is 10, our starting position. And we could then, in update, which is called 30 times a second, just say expose plus equals 1, which means the same like expose is expose plus 1. And then we say expose, and if we type run, we can see our little sprite move, which is pretty neat. By the way, sprites in Lua are not sprites like on the C64. So the C64 had real hardware sprites, which meant that the CPU didn't have to handle any kind of sprite activity. This was all handled in the VIC-2 chip. And sprites in Lua or in PICO-8 are just normal graphics paint on the screen. But still, since the modern graphics cards are able enough, that doesn't hinder the machine to display 128 sprites at a time. What you can also do is you can just draw a pixel, and that is with pset, and you say the position, let's say 100, well, let's use the center of the screen, 64, 64. The screen is 128 by 128 pixels. And the color, let's say 3, I have no idea what color 3 is, and there's a green pixel in the middle of the screen. You can also read the color of the pixel on the screen, which is pget. Shift again, which is pget, and you just say which pixel, 64, 64, and we can say print, and then we want to know the color, and which is 3. It's printed in the left top corner. You can also draw rectangles, circles, and lines. So to draw a rectangle, you just say rect and starting position, let's say 2020, and then you say the x and y coordinates where the rectangle has to end. It's not the width or the height, it's exactly that, and a color, which could be, let's say 4. And that should give us a 20 by 20 rectangle. Let's see if this is correct. What if we type 2020? Should just be a pixel. Yeah. Okay, same goes for circle, which is circ. And again, this time you define the center of the circle, I guess. And the radius, let's say, is 20. So we should now get a circle around the top left edge of the rectangle, and the color, say 5. Yeah, and that is exactly what we get. And last but not least, we have the same in fill. So we have rect fill, and we have circ fill, used just like these, but in the filled version. And we have the classic line command, which is from, let's say, 2020 to, again, this is not the length, but the exact pixel on which this has to end. Let's say 60, 60, and a color of 6. We have to delete this. And there we go. Then we have stuff like a camera to move around, which is interesting for maps and map handling. We have sound, which we can play, and we have different math functions to do calculations like collision detection and stuff like that. So if, for example, we wanted to draw a map, let's try this one. Let's say we do a simple Earth and a simple wall. We could now go and create a map using these by just drawing this on the screen. And if you want to display this map, we just go in the code editor and we say map, and we say which cell, and we want to start at 1, 1, which is the top left corner of our map. And we say the screen X and Y, which is 1, 1, because we want to put it right in the top left corner. and we tell it how many cells, and we want 16 by 16 because that is the full screen. And that should display our map. And there it is. It's on top of everything else, so that is not the intended purpose. To change that, we could just draw the map first, and all the other stuff would be drawn on the map then. So you can see now the circle and the line, all the stuff is over the map. So these are the basics of the Lua language. There's quite some more stuff here, especially if it comes to keyboard joystick handling and stuff like that. We will use this in the game, but this is a little bonus video just to show how to do stuff in PICO-8 on a very basic level and to understand the language and all that. Yeah, so that is the end of this video. Thanks for watching, and if you liked this, give it a thumbs up. Appreciate it, and in the next episode we will take a look at the sprites and how to handle these and to get a player sprite running around on the screen. Bye-bye.
Thank you for watching Retro is the New Black. If you're new to the channel, please like and subscribe. If you like the video, please share. Every like, share, and comment helps a lot. Until next time, bye-bye.